Okay, so what I'm presenting in this video is the lane finding algorithm part. I'm going to present it, I'm going to explain how it works, and I'm also going to go a little into the details of how the behavioral neural net works because I feel that I didn't quite explain how that worked. I just presented it. So I'm going to explain how that works as well, like just the basics of it. Okay, so right now what I have here, I've paused the game for a moment. We have in front of us a lane that is curving towards the left, and our car has a very negligible amount of offset in the lane. Okay, so if I resume the game, I should be able to see the offset and the radius of curvature. The negative offset means you are a little to the right of the middle, and the negative ROC means the lane is curving towards the left. As in the offset is in terms of where you need to go. If the offset is basically telling you to go towards the left because you're on the right side of the lane, and the ROC is telling you to go towards the left. The negative ROC means go left. So I'm now gonna explain how that works. I'm gonna stop that, and I'm gonna run another script. Yeah, okay. Just a second. Okay. Right. This isn't exactly the best example. I didn't quite think about it. So I'm just going to pause the video. Okay, so I've changed the location. The road is now a little bit brighter, so it's able to see the road better. So the way this algorithm works is that it takes the image and then it sort of does a lot of thresholding, and it figures out where these lane markers are. Once these lane markers, yeah. Okay, so it figures out that the lane markers are here somewhere and then here somewhere, and then this is actually if I were to color this image, this would look a little bit like this. It would not be an entire image. It would just be this region, which I'm like sort of creating with my cursor. And that's like the region of interest that I have because I know that the lane markers would be somewhere in there. Then what I do is I take that region of interest and I sort of transform it or warp it towards the edges. So basically now the view that I have is like an eagle's eye view. Once I have this eagle's eye view, I can then fit a second order polynomial onto both of these, and from that I can figure out the radius of curvature of the lane. And if I know the positions of these guys, I can take their average position on both sides, and then the average x on this side and the average x on this side, I take the average of those two guys and I get the center point. And the farther away that center point is from the center of the screen, the more the offset I have, and the more I need to shift the car towards the right or the left, depending on how much the offset is. So yeah, that's pretty much how the lane finding algorithm works. And uh, as for the neural net algorithm, where is it? Just a sec. So the way that in which that the neural net algorithm works is that um, it takes an image. Where's my mouse cursor? I hope the mouse cursor is below. It takes this frame, as in it takes a screenshot of my screen, but only is in this region. I have to like specify the region in which it has to take the screenshot, and once it has taken that screenshot, that an image is then right. I have this right here. So I take that. I hope the code is visible. Okay. So I take the image, which is it grabs the image from the screen within this bounding box. Then it takes that image, it converts it to gray image, grayscale, because my neural net cannot process colored images, and it would take a lot more processing power to process colored images. 3 times the processing power to process colored images. This is just the roadmap. Like I know the location of the roadmap in the game, so I'm like figuring out the location of the roadmap, and where is it? Oh God. Okay, right. So this is just the roadmap image, and I then take both of those images, like the main image. I squish it down to an 80 by 60 size, and then I take the roadmap image, and that is also of an 80 by 60 size, and I put them side by side, and that is what is fed to the neural net. The neural net basically looks at both the map as well as the road in front of it, and then figures out what it should do based on what it has seen me doing. And this is basically the implementation algorithm, the thing that you run when you want to make the car drive by itself. So it's just taking those images, it's concatenating those images, and then it's feeding it into the model. Like it's asking the model to like then predict what is supposed to happen, and then I get my inputs. I get my control actions from the model, uh, and then I figure out how much forwards, backwards, left, right it's supposed to go, and then I just implement those forward, backward, lefts, and rights. So yeah, I'm not like tampering with the game or anything. Like I'm not figuring out where the objects are in the game or anything like that. I'm doing like computer vision related stuff. I'm like feeding that image to a neural net, and then that neural net is figuring out what's to be done. The neural net does not actually know that these cars and cars are objects, and it doesn't know where the road is or anything like that. Yeah, okay. So that's pretty much how that thing works. And to train it, it's pretty simple to train it as well. I just have to hook up a controller to my laptop. I don't have that controller right now. I hook up that controller, and there's another script that I have created which basically records these images, and it records my control inputs at the same time. And that is basically how I create my data set. Like it basically annotates the images in real time. So I don't have to spend any of my time annotating the images, and then I balance the data by basically counting the number of times I went forwards, left and right and back, and then I sort of make them all equal, as in the number of lefts and rights are much lesser in comparison than the number of forwards. So the number of forwards are reduced to the number of lefts and rights. I should have a Python script for that if you guys want to see it. Data balancer, data balancer, data balancer, there it is. Okay, so yeah, it's like it takes it, it loads the data, and then it just makes it into a data frame. Then I create a list, a bunch of I create a bunch of lists, and then I take the my camera is misbehaving a bit. I take the stuff, and then I like figure out if it's going forward, left, backward, or right. And here's the balancing part. Yeah, so that's pretty much it. That's pretty much it for the balancing part. Thank you.